Hi everyone, Mike Stuchiner, Master Herbalist here with Z Natural Foods. And today's video is going to be basically a wide range of topics regarding protein and protein powders. But before we get started, I have two things to mention. One, more information about me, please go to my YouTube channel at A Master Herbalist's Perspective. And number two is our health disclaimer. The information you're about to hear is for educational purposes only and is not intended to treat, prescribe, or diagnose any general or specific medical condition, and is not intended to be a substitution for your primary healthcare provider's diagnosis, medical information, and treatment protocol. With that said, let's get started. So in today's video, I'm going to review three aspects of the overall topic of protein and protein powders, which is number one, what I consider to be two of the biggest myths surrounding protein. Number two is I'm going to discuss the 9 essential amino acids. And number three is the 4 criteria that could be utilized as a tool in helping you decide what could potentially be the best source of protein for you as an individual. I want you to keep in mind that these 4 criteria are not perfect. They are just specifically used as general guidelines and general tools for you to help make a better educated decision. With that said, let's get started. So, I'm going to begin by discussing what I consider to be two of the bigger myths in the world of protein. Myth number 1, denatured proteins are entirely useless. Ha! That is so untrue. But in order to discuss this topic correctly and give the best information, it's vital to understand the difference between an undenatured form of protein versus a denatured protein. In simple and easy terms, undenatured protein are pure, properly functioning proteins without any structural deformation, intact with all bioavailable nutrients and constituents. Looking at undenatured protein from a bird's eye view, because it, by definition, is considered the purest form of protein, because again, it does contain all of its bioactive nutrients and compounds, it is easy to say from a bird's eye view that it's better for you than an undenatured protein. For example, undenatured whey protein has many components like beta-lactoglobulins, alpha-lactoalbumin, immunoglobulins, and lactoferrin. So this is generally going to be, by definition, a better choice for all intended purposes. We must note that at Z Natural Foods, we don't use the term unprocessed to define an undenatured protein, because everything at some point goes through some processing to create an end product. For example, whey protein isolate goes through a precise filtration process that removes the lactose and produces an end product yielding higher amounts of protein per serving with less fat and carbohydrates. Because no chemicals and heat were used in this process, the protein bonds were not weakened. So whey protein isolate is, by definition, if no heat has been used in this filtration process, can still be considered an undenatured protein. Denatured protein is the alteration in what is known as the folding patterns of a protein by heat or chemical reaction from its original formation. This process has various degrees, and it's crucial to note that your body does naturally unfold protein through the digestive process. Protein function depends on its structural shape, and heat causes protein to vibrate, which weakens the bonds that holds their complex shape. When a protein has become denatured, it is no longer considered functional in the same elaborate manner. That statement I just made comes with a massive caveat. The fact is, there is absolutely nothing wrong with protein that has become denatured through cooking with heat or some other process. We eat these forms of protein all the time. As a matter of fact, athletes all over the world who prepare their meals ahead of time often use microwaves to reheat their food. Do these people look malnourished to you or look like they lack quality protein to you? In case you're wondering, the answer to that question is no. For example, a hard-boiled egg is regarded as a form of denatured protein. The heat used to make the hard-boiled egg changes its structural integrity. However, it still has excellent nutritional value and all of the essential amino acids to create a complete protein. Another example is when we cook meat on the grill or microwave our food. These are forms of cooking process or cooking processes that change the protein's structural integrity. Yet, it does not change the values of being a complete protein. Finally, one last item I want to mention in this little category is some products are actually purposefully created in their denatured form to produce a faster absorbing form of protein, like partially denatured whey or a hydrolyzed whey protein. Okay, there's many forms of whey protein, isolate, concentrate, and the third one, which a lot of people don't tend to really talk about, is what is known as hydrolyzed whey, which is by definition a partially denatured protein, and is purposely made that way so your body can utilize it in a more efficient manner. Myth number 2, the body can tell the difference between animal protein and a mixed plant-based protein source regarding the presence of essential amino acids that is related to creating a complete protein. So before we debunk this myth, let's review some basic protein amino acid facts. There are 20 different amino acids that your body needs for various functions. 11 of the 20 are produced by the body, called non-essential amino acids. And the other 9, which are called essential amino acids, we must get from food, and the body can't produce them. Amino acids are organic compounds and building blocks your body uses to make protein. A food is considered a complete protein when it contains all 9 essential amino acids, which I will go over a little bit later in this video. And it's important that you understand that fact, because here is what we know about basic physiology and protein metabolism. Proteins are not stored for later use. The body converts excess protein into glucose and triglycerides to supply energy and build energy reserves. When we eat a complete source of protein, the body breaks it down into amino acids to create what is known as muscle protein, along with a host of other proteins in the body for enzymatic reactions. The 9 essential amino acids also act as what are known as regulatory signaling molecules. Now, suppose we starved ourselves or only ate incomplete protein sources for weeks or months on end. In that case, there is a process called essential amino acid recycling, where we pull amino acids from muscle tissue to create protein. Essentially, the body breaks down for which is basically where essentially the body will break down for survival. This is clearly different from the desired goal when creating optimal health. So, in simple terms, all the body is concerned about is having all 9 essential amino acids present when specifically creating muscle protein and enzyme proteins. The overall result is the same whether the protein comes from a single source of complete protein like eggs, whey, and beef, or combined sources to create a complete protein like what you often find in plant protein mixes. To be clear, this is not to say that other factors don't affect the value and utilization of different protein sources, which again, I will go into later into this video. Now, let's discuss and examine the importance of what all 9 essential amino acids actually do. So, histidine is the first one. It helps to make a neurotransmitter called histamine that plays a vital role in your body's immune system, digestion, sleep, and sexual function. Isoleucine, which is one of the 3 branched-chain amino acids, supports your body's muscle metabolism and immune function. It also supports your body's ability to make hemoglobin and regulate energy. Leucine, again, another essential, not only is it an essential amino acid, it's one of the 3 branched-chain amino acids, supports your body's ability to make protein and growth hormones. It also helps grow and repair muscle tissue, heal wounds, and regulate blood sugar levels. Lysine is involved in the production of hormones and energy. It is also essential for calcium absorption and immune function. Methionine supports healthy tissue growth, metabolism, and detoxification. Methionine also helps absorb essential minerals like zinc and selenium. Phenylalanine is essential for producing your brain's chemical messenger, several of your brain's chemical messengers, including dopamine, epinephrine, norepinephrine, and the absorption of other amino acids. Threonine may support muscle, protein, collagen, and elastin that provide structure to your skin and connective tissues. It also plays a vital role in fat metabolism. Tryptophan helps maintain your body's correct nitrogen balance and supports the production of neurotransmitters, serotonin, that regulate your mood, appetite, and sleep. And the final, which is number 9, which is the third of the 3 branched-chain amino acids, is valine, which is involved in muscle growth, tissue regeneration, and helping to produce energy. A study titled "A Novel Plant-Based Protein Has Similar Effects Compared to Whey Protein on Body Composition, Strength, Power, Aerobic Performance in Professional and Semi-Professional Athletes," compared the effects that whey protein and plant protein have on strength, power, body composition, and aerobic performance. It was concluded that whey protein does not possess any unique anabolic properties over and above those of plant proteins when looking at specifically the essential amino acid profile. It should also be noted that this study did not have a conflict of interest in the company affiliated with the study which happens to produce plant-based protein products. Finally, it's essential to discuss a process called protein synthesis to understand how the value of protein is made from amino acids. Protein synthesis is the process of cells producing a polypeptide, which is a protein made out of a chain of amino acids, and a significant route of disposal of amino acids. The process occurs in two stages: transcription and translation. Amino acids bind to specific molecules of transfer RNA and are assembled into a sequence specified by RNA messengers, which in turn is transcribed from the DNA template. I know that that's a lot to take in, but in simple terms, transcription is the transfer of genetic instructions in DNA to mRNA in the nucleus of the cell. Finally, I'm going to discuss the criteria for determining the 4 criteria that, as I mentioned at the beginning of this video, for helping you to determine and make a better educated choice when it comes to your best source of protein for you as an individual. The critical factors determining this end result are the 4 following aspects. 1, protein efficiency ratio. 2, biological value. 3, net protein utilization, which is how much are we actually using. And the 4th is protein amino acid profile. So let me review each one of these in very simple terms. Protein efficiency ratios measures the nutritional value of protein sources, which PER determines the results by dividing weight gain of a test subject by its intake of a particular food protein during a testing period. To date, this method has only been done on mice and rats, but it is believed that aspects of results do actually correlate into humans. In a study looking to assess in vivo and in vitro quality methods, protein efficiency ratios and net protein ratios of 15 different sources of protein, rats were fed a 10% protein diet for 14 and 28 days. The protein qualities were expressed compared to casein, which is across the board considered in studies one of the top protein sources. The results determine the following. Values of non-fat dried skim milk and tuna were more than 100% that of casein. Non-fat dried skim milk, chickpeas, and breakfast sausage were between 50 to 70% of that of casein, and pinto beans and rice did not support substantial growth of the rat. The NPR method did not always rank the protein source in the same order as PER methods. For poor quality protein, RNPR values were much higher than RPER values. However, the RNPR and RPER values agreed closely for high quality protein sources. Based on PER, protein efficiency ratio parameters, the top 3 proteins are egg, whey, and meat. The second criteria is net protein utilization. The ratio of amino acids, mass converted to proteins, to the abundance of amino acid supply. In simple terms, net protein utilization describes how much protein our body can use compared to what we ingest at a given time. It's vital to note that this concept is severely affected by the level of limiting amino acids in any given food. An article in the American Journal of Clinical Nutrition discussed the ingested protein dose response of muscle and albumin protein synthesis after resistance exercise in young men. It was concluded that consuming 20 grams of intact protein maximally stimulates muscle protein synthesis and albumin protein synthesis. Leucine oxidation was increased after 20 and 40 grams. This is important because leucine can potentially prevent muscle breakdown. The top 3 contenders using this parameter are egg, whey, and beef, again, which is again important. Number 3 is what most people commonly talk about, which is biological value, which measures how efficiently the body utilizes each source of protein from the diet. Foods with a high biological value correlate to an increased supply of essential amino acids. The equation of biological value is calculated from the nitrogen used for tissue formation divided by the nitrogen absorbed from food, then multiplied by 100. In simple terminology, it's the percentage of nitrogen utilized. Nitrogen is a core component of amino acids and the building block of protein and nucleic acid, and the building block of genetic material. With regards to this specific marker, again, the top 3 proteins that take the reign with regard to best biological value: whey, then egg, followed by beef. The 4th and final is called protein amino acid profile, which looks at several factors regarding the amino acids present in a specific source of protein. First is whether all 9 essential amino acids are present to create a complete protein. Next is whether particular amino acids are in higher amounts than others for optimizing specific results. Both animal and plant protein comprise around 20 amino acids, and the proportion of these amino acids varies with each source of protein. Amino nitrogen accounts for about 15% of a protein's total weight. For clarity, this specific parameter is only relevant if you are being consistent with your baseline diet and trying to increase levels of specific amino acids to obtain a particular result. For example, higher leucine may prevent muscle breakdown, or higher proline, glycine, and hydroxyproline may support collagen levels. So this specific criteria, looking at the amino acid profile, is very much more specific when it comes to looking at if you're trying to obtain a very targeted result. So guys, I know that this was an awful lot of information to throw at you, but these are all factors that really play a very significant and relevant role when we look at the general topic of different sources of protein and how well our bodies utilize. In the end, while all of these are relevant and all of these play a role, it still does come down to you as the individual, how you respond, and looking at and tracking your individual results. So with that all said, Mike Stuchiner, Master Herbalist here with Z Natural Foods. I'll see you next time.